Hello, how is everyone doing today? Welcome back to our Solidity webinar. And we're continuing from where we stopped yesterday, where we looked at inheritance. So today we're digging into two important concepts in Solidity inheritance, that is shadowing state variables and calling parent contracts. And before we begin coding, I just wanted to give some definitions and concepts. For example, what is shadowing? And shadowing is the act of declaring a new variable or function in a child contract that has the same name as one in a parent contract. For state variables, this is explicitly disallowed in modern Solidity because it can lead to confusion and errors. But for functions, it is allowed and encouraged using the override keyword, what we were looking at yesterday. Then you have what we call an event. An event is a way for a smart contract to emit a signal for a log that external applications like Web UI can listen for. Events are not readable by smart contracts. They are stored in the transaction log on the blockchain, providing a cheap form of historical data storage and debugging. They are defined with the event keyword and triggered with the keyword emit. So that's event and then emit. And then we have what we call direct parent call, calling a parent's function by using its contract name. For example, when we looked at yesterday, we had something like that. So this calls that specific function from that specific contract, regardless of the inheritance hierarchy. Then we have the keyword super. It's a special keyword that does not refer to a single parent contract. Instead, it refers to the next contract in the linearized inheritance hierarchy. In complex multiple inheritance, super can trigger a cascade of function calls up the inheritance chain, following the rules of linearization. Then, maybe just to brush up on what linearization again means, the C3 algorithm. That is the process Solidity uses to flatten a complex inheritance tree into a single deterministic order. This order dictates the path that the super keyword will follow. The simple rule is parents are ordered from most base to most derived. And when multiple parents are listed, they are prioritized from right to left. So let's look at our first bit of today's webinar, which is shadowing inherited state variables. Let's start, and then I'll break it down after I finish. Okay, let's break it down. So yeah, we declared a smart contract named A that contains a string, which is contract A. So the string obviously is the data type of the state variable as a string. The public is a visibility modifier, makes the variable readable by anyone, and also automatically gets or creates a getter function called name. Then name is basically the name of the state variable. The contract A in the double quotes initializes the state variable with the string value. So contract A at the time of contract deployment. And then it has a function called getName. It is also declared public for visibility, meaning it can be called externally. The view is a state mutability modifier, meaning a function promises only to read from, not modify the blockchain state. Then return string memory specifies that the function will return a string value located in memory. And then line 8, return name. The function's return statement, it returns the current value of the step variable name. Okay, I'm seeing there's a one in here. Oh. So this is commented out because shadowing in Solidity 06 and above is disallowed, and as you can see the version we're using is 08. So that's why I did that. Then from line 17 we declared a new contract C that inherits from contract A using the is keyword. This means C has access to all public and internal members of A, including the state variable's name. And then we have a constructor from line 19 Well, we've declared the constructor function, which is a special function that runs only once during the contract's creation. In that function, we have name is contract C. This is the correct way to override an inherited state variable. So name is equal to, because C inherits from A, the state variable name already exists in C's storage. So this line of code reassigns the value of that existing storage slot from contract A. When I'm talking about contract A, I mean what we put up there. So from contract A to our new value, which is contract C, when contract C is deployed. So again, this line reassigns the value of that existing storage slot from contract A, where this new contract C is inheriting from, to contract C. Because remember, in memory it has this. I will deploy both at the end, but we can then go on to calling parent contracts. I think I forgot to summarize what does, or what it's showing basically. In summary, the previous example, which is this one, demonstrates that you cannot override a state variable by redeclaring it in a child contract, and this is called shadowing and is forbidden. So instead you must change its value through a constructor or a function. So let's move on to part 2 of what we're looking at today, which is calling a parent contract. So this is our second part of today's lesson, which is calling parent contracts. So from line 4 we declare the base contract A. Line 5 saying event log string message. Event is the keyword to define an event. Log is the name of that event. So we have an event called log. And string message, so the event can accept one parameter of type string that will be stored in the transaction log. This is used for debugging and tracking. And then line 7 function foo public virtual. We've declared a function foo, or function called foo, that is marked virtual, allowing child contracts to override it. In line 8 emit log A.foo called. The keyword there is emit, which is used to trigger the event or an event. And then the log A.foo called, it fires the log event, passing the string A.foo called to be recorded in the log. So this acts as a traceable message. And then in line 17, contract B is A, declares that contract B, which inherits from contract A, has a function foo. This is where we are now. Yeah, this line. Public virtual override, so it overrides the virtual function from contract A. Yeah, so it overrides the function A.foo. The override keyword is mandatory. Emit log B.foo called, so it emits a log message indicating that B's version of foo was executed. And then line 20 here. So that is a direct call. It explicitly calls the foo function from contract A and nothing else. It does not consider the full inheritance hierarchy. Then line 23, function bar public virtual override overrides the bar function. And then we have emit log b.bar called, so it emits a log message for b.bar. And then line 25, super.bar, this is a super call. It does not call a.bar directly, instead it calls the bar function from the next contract in the inheritance hierarchy chain. For contract B alone, the chain is simple. A to B, so super points to A and A.bar is called. The power of super becomes clear in multiple inheritance, like we'll see in contract D, which is which is what we're going to skip to next, because this contract here basically borrows the same logic from this. So let's go to contract D is B, C. So we've declared a contract D that inherits from both B and C. The order is BC, which is critical for linearization. Then the function foo public override BC overrides the foo function from both parent contracts B and C. The override keyword must specify all the parent contracts. Then line 43, we have super.foo. This is where basically the critical stuff happens. So the linearization for D is B. The linearization for D is B. C is basically A to B, then B to C, and then C to D. So the super call in D looks for the next function in the chain. It finds and calls here. C4. And C4 basically emits C that foo called, and then makes it a direct call to A foo. So the resulting logs would be C foo called followed by A foo called. Then we have the function bar public override BC, so it overrides the bar function. Then super bar, again due to linearization, it's A to B to C and then to D. The super call in D calls C bar. C bar will emit C bar called and then calls super bar in the context of C, which is the next contract in the chain. So the next contract in the chain is B, because C only knows its inheritance is A to C. The full chain of D is merged. Then B bar is called, it emits B bar called and then calls super bar in the context of B, and then the next contract is A. A bar is called, emitting a bar called, and the resulting logs will be C bar called, B bar called to A bar called. So this shows how a single super call in D cascades up the entire inheritance tree. Basically, that's what we're expecting to see in the terminal when we call the functions. So don't expect to see any data inputted, we'll just be reading. And this is, Specification of this. Contract C, contract C. So that's the parent contract here. Barcode let's deploy the D, because I think that's where most of the action takes place. I don't think I know. And then what's the first thing we should do? Let's first call the foo function. So yeah, A.foo called, and then A.foo called. Right, that's the first one, and that's the second. Now, if we call the bar function, we should expect to see 3 emitted events in a certain type of order. And if we expand this, so it's C barcode, B barcode, and A barcode. As expected, that's the order expected. Okay. Yeah, so that's it for today. Thank you for tuning in. That was shadowing state variables and calling parent contracts under the topic of inheritance. Thank you for tuning in. Please don't forget to like the video and subscribe to the channel, leave a comment, share the video as well. I'll see you guys next week. Have a blessed evening.